Hello everyone, welcome to my channel Civil Softwares. We were solving the Truss models. In our previous videos, we already solved this question. Now in this video, we are going to solve this Truss. So let's get to our work. So first of all, go to this app, then click on File and click on New Model. So first we need to set the units. It's kilonewton, meter and Celsius. It's okay. Then we are going to select on grid only. And for this, let's go and see how many X grids do we need and in Y and in Z. So in this question, okay, for X direction, we are going to keep 1 grid, 2, 3, 4, and 5 grids. Okay, let's keep 5 grids along X direction, and in Y direction, we do not need in Y direction. So let's just keep 1, and in Z direction, we need 1, 2, and 3 grids. So let's keep 3 over here. Now for the grid spacing, let's see for X direction, it's 19, it's 38 over here. That means if we go over here, it's 19 and 19. So it's 19, 19, 19 each. Okay, so in X direction, we are going to keep 19. Y direction, it does not matter because we have only one grid. So no need to care about the spacing. In Z direction, let's go and see, it's 19 and 19, right? 1, 2, 3 grids we provided, and it's 19 each. So let's go and click on 19 each. Okay, so let's click on OK. Now it gives us this model, and now we are going to apply our members in this frame structure. Okay, truss structure. So it is in XY plane, so we are only seeing one line over here, but we need XZ plane. So let's select on XZ plane. Okay, now we are going to assign the members in this truss, right? So at first, let's not forget to define and go to the load patterns and select self weight multiplier as 0, because we are not defining any kind of sections over here, and we are not adding the self load. We are going to only see how the load reacts. Okay, so click on OK. Now we need to apply the member loads on this structure. So let's go and select on the frame cable. So here we are going to have a straight frame section. We have not defined any kind of sections and kept 0 as self weight multiplier, so keep it as it is. So its moment release is continuous, it's okay. And now we need to model it, right? So at first we have this member going this way, right? Okay, we start from here, we go here, then we reach here, or that we go all the way there and there. Okay, all the way here, then we go here. Okay, then we go over here. After that we have this section. Okay, from here to here, then here, here. You also have this member, and we have this member. Do we have any other members? We do not. So I think this is it. Okay, so we are done with assigning the members. So now we need to apply the restraints in this supports, right? So let's see what are the supports. Hinge is at this place and roller support at this. Select on this point, go to assign, go to joint, go to restraints, click on hinge support, click on apply. At this point we have roller support, go to roller, click on apply, click on OK. So we are done with assigning the restraints to. Now we need to apply the loads, right? So let's see what kind of loads do we have. Okay, the loads that we have is 42 kilonewton here. It is along the gravity, or 18 kilonewton, then 42 kilonewton along the x direction. Okay, so we have altogether of 3 loads. So at first let's go to this section and apply 42 kilonewton at the center. So click on the section and go to define, go to assign, go to frame loads, go to point load, because we are applying the point load over here. So now in this section, the 42 kilonewton load is exactly at center. So I'm going to go to the relative distance from end eye. Then at 0.5 distance, that means at half distance, exactly at half, I'm going to apply 42 kilonewton load. And at other points, it's 0 because we do not have any other loads in that section. I'm going to click on apply. So it keeps 42 kilonewton exactly at the center, right? Click on OK and let's confirm it. Okay, so at this section we are going to assign 18 kilonewton load. Select this section and go to assign, go to frame loads, go to point load. So it is at this distance, right? So and our spacing is 19 19 19 each, right? So we have loads at this point. So it's 19 plus 38. If we take absolute distance, it starts from this section, right? So if we click on absolute distance, now we have to calculate the distance from this starting point up to this point. So it's 19 19 19, 3 times 19, that means 57. Okay, at 57 units we have 18 kilonewton load, and at other points it's 0. Click on apply. Okay, here you can see 18 kilonewton load appeared at this point. So what does this show? This shows that the starting point is chosen from this distance. So if you click here and just click on 19, then it is going to give correct result. Click on apply and click on OK. So you have to be clever with this grids. Okay, so we need loads at this point anyhow, so we need to apply here. Right now we have applied the loads 42 kilonewton and 18 kilonewton along the gravity. Now 42 kilonewton we need to apply horizontally, right? So let's click at this section and we have 42. Okay, click on assign, go to frame loads, go to point load. Okay, go to point load. Okay, go to point load. I'm going to select relative distance over here, and since it is exactly at the end, so it's at 1. So at any other point, let's keep 0, and at 1 means at its full length we are going to apply 42 kilonewton load. But we need to make sure about the direction of it. It's in gravity, but we do not want it along the gravity. We want along x direction, right? We want along x direction in the global axis. Load type is force. Yeah, so let's click on OK and see what comes. Okay, so 42 kilonewton load has been applied to this point. So now you can see here that, okay, I will explain it. Click on OK. You can see 42 kilonewton load along the gravity was here, but now it's gone. So let's see if it is hidden or if it is deleted because of assigning this load. Click on this section, just right click on it. Okay, and you can see the loads. So it's 42 at 38 along x direction. That means our 42 kilonewton load gravity is gone because we have done one mistake over here. I will tell you what. Go to this point, click on assign, click on frame loads, go on point load. Here you can see replace existing load. So which means any load we add to this member, it's going to replace the previously added load. So we have to click on add to existing load so that all the loads remains. So now for now we need to choose gravity because we are applying 42 kilonewton load along the gravity, right? So it is exactly at 0.5. Okay, it's 42, and at any other place we have to keep 0. So now it is not going to delete this 42 kilonewton load because we have clicked on add to existing loads. So click on apply, click on OK. So we have all the loads here, right? Now we need to run this, and we just need to do not run this model case because we are only seeing this dead load case. Click on run now, and we need to save here. So okay, save anywhere. So this is our axial force diagram, and here you can see 0 errors. Okay, so done. Now if you want to see the undeformed shape, then you can go and see show undeformed shape. This is our undeformed shape. Our analysis is locked. Here locked, it means we are on the analysis uh, mode. So let's go and select the show deformed shape, and we are in the dead load combination. Yeah, apply. Okay, so this is our on deformed shape. So if you want to see the joint reaction, just click here and go and select joints and click on apply. So what you can see over here is for 4.5 here, for 4.2 here, and 55.5 here. So okay, let's for clarity, let's select this page and let's see the reaction of this. Okay, because it is in 3D, it's a little bit difficult. So here you can see 55.5 along z direction and along x and z. You can see the reactions here. If you want to see in the tabulated form, go and click on apply. You can see the values over here along with the directions. It's given over here. Okay, now I'm interested in seeing the axial force diagram. So click on this, go here, frame cable tendons. Now click on axial force. It's already clicked, so click on apply. Okay, so this is going to give us the axial force diagram. So now if you want to see the details of any members of this section, you can just click over the section and just right click on it. It's going to give the detail. If you can also click here and see different values. Okay, so in this way, if you can model the process very easily. Thank you for watching this video. Bye bye.